Okay.
All right, good afternoon and welcome to the DC and Hybrid AC/DC Microgrid Design webinar series presented by eMERGE Alliance, a trusted RE+ events partner. Thank you for joining us. This afternoon's webinar is Microgrid Design for Commercial Buildings. There will be a recording available afterwards for viewing on the RE+ events website, that is re-plus.events, at the end of the workday that will be open access. If you have any questions, please submit them in the Q&A chat and they will be answered towards the end of the webinar. And now it's my pleasure to introduce today's moderator, Dusan Berlik, co-founder and CEO of Direct Energy Partners.
Thank you for the introduction, Trisha, and thank you for the opportunity to host this microgrid design webinar series. Today will be, it's my pleasure to introduce the panelist, Mario Barbaresso, who's the president and CEO of CE+T America. And together, jointly, we will be discussing and the value proposition of microgrids for commercial buildings and facilities, and also going through an actual design. So thank you for joining, Mario. And at this point, I would like to give Mario an opportunity to introduce himself and his company.
Well, good afternoon, Dusan. Good afternoon, everyone. Thanks for inviting me. Yes, I am the CEO of CE+T America. We are a subsidiary of a international conglomerate based in Belgium, but our company, CE+T America, is based in Atlanta, Georgia. We specialize in design manufacture of complete solution for backup power systems and energy systems. We provide solutions to data centers, utilities, telecom, C&I customers. Usually our solution is modular and provides some kind of a ROI to all of our customers. We have three pillars in our strategy: is zero downtime, zero cost, and zero carbon footprint. That's what drives our own company. As you can see, we've been voted best managed company since 2018. The next one will be in 2023 and 2024. We expect the same award. A few years back, we won $1 million with the Little Box Challenge with Google. We designed a very small, the smallest inverter in the world. That was designed by our team. So this is to say that we are creative, we're innovative, and we like to work with customers and partners like Dusan to design unique and best energy solution for our customers.
Well, thanks for the introduction, Mario. And you guys definitely have one of the most flexible products on the market when it comes to microgrid design. And so today, we will be doing a commercial design of the product, which is the Stabiliti. And in order to help us facilitate the design series, we will be using our software called DCIDE. DCIDE was created specifically to be able to ideate at the speed of thought. And so today we're going to put it to practice and also introduce some of the value that DCIDE adds for microgrid designs. So Mario, I touched a little bit on it, but today what we want to do is talk about, how the Stabiliti series product provides value to commercial buildings. So can you talk about maybe a problem statement that you can address with the Stabiliti product?
Well, what's important to understand is the Stabiliti product is a 3-port converter, 1 AC and 2 DC. So the AC port allows us to have a shunt or parallel connection to the service line. It's bidirectional. So it can feed into the line or receiving energy from the line. And it does power two DC port with galvanic isolation. And those DC port can be configured as battery chargers, MPPTs, connection with fuel cell, anything that has an MPPT or a DC power would be involved in connection on the DC side. So we have the 2-port version, which is just the inverter, and we have the 3-port version. And what you're drawing right now is a fast single line diagram of on the left side the 3-port where we see the AC connection. What's important is that on your AC input, it's important to understand that this is tapping onto the existing service line, so your load is on that line. So this is feeding straight into your service panel. So the Stabiliti is shunt connected, so it's an add-on to what you already have. So one of the challenge we have with many of our customers is to manage the interaction with an existing AC generator. So that is usually provided on the AC line. So what does it do is obviously backup power with batteries is expensive. So what we see as an application is, for within 1 hour to 2 hours, the battery will take charge of the load. Over that, the generator kicks in. That would be the traditional way of operating with a generator. It would be an and or operation. But what we see today, because of the change in energy tariff, requirements of arbitrage, and even peak shaving, the system has to be able to work in conjunction with the generator. And that is where the design of the system and the converter is very important, because working with a generator has to be understood that one source has to be the leader. So in our science, we call that leading power factor, right? This is you have to decide who's leading, and who's lagging. And we always have to keep in mind that a generator is not meant to be lagging. If suddenly the generator considers and measures himself like a load, well, the governor on the generator will shut everything down. And then you could be actually using the generator, and you could be in a very bad situation where you need that power, and suddenly the generator goes down, because what happened is the generator sees itself has a load and disconnects and shut down itself. So this ecosystem has to be able to balance the energy coming from the battery and coming at the same time from the generator. And you want to have these two working in conjunction to limit the consumption of the gas consumption, and also limit the amount of battery reserve you have. So there's a lot of benefit in working in conjunction like that, while also using solar panel to come in and add energy to charge the battery. So this entire ecosystem is about balancing and making sure that the generator leads the pack and allows the battery to contribute to the energy. So your tool here, I mean, in just 10 minutes, you were able to illustrate what we're talking about. You've shown the direction of the energy being bidirectional everywhere, except of course on the solar panel and on the generator. And that's important for installers or user to understand that those energy flow cannot be changed. This is just physics, and needs to be respected by the converter and by the whole control of the whole system.
Exactly, because you have your typically have like your sources of generation, which is like your solar panel. And I know from designing with solar systems, solar panels are considered as a current source, right?
Yeah.
So as soon as the radiation comes up, they just kind of pump current in. They're not a voltage source, whereas the batteries are your voltage source.
Yeah.
And so the stability, can juggle effectively which of the ports needs to be a current source or voltage source, when do you use sink power or source power. And so from my particular experience with this unit, it's from that perspective, it's super flexible. From the design tool perspective, what I did here within seconds as you were talking, the purpose here is to be quickly able to differentiate between AC systems, which are represented in red, and DC systems, which are represented in blue. But also because we pull products in, like we pulled your real product in and we have your specifications in here, we can immediately determine if you're attaching a solar panel to your converter, if it should be bidirectional or unidirectional. So with DCIDE, we're trying to fill in this knowledge gap so we can really focus on the application.
Right.
With that. And so same thing here, your generator also provides power one direction with that. So even though, Mario, we're showing a unidirectional port here, technically this port for your stability can be reconfigured for bidirectional power.
That is correct. That's correct. Thanks for saying that, because you can have those DC ports are flexible enough to add a second set of battery, or you would have one DC port to charge your battery and the other DC port to have a DC bus, where the behavior of the DC would be more to maintain a certain voltage instead of charging a battery. And that DC port would create a DC coupled network in a facility where LED lighting could be added on, or any DC load could be added on. So that's a difference between using the DC port as battery chargers or using your DC port as a rectifier with voltage, constant voltage. And that's what can be done with the stability. Correct.
Yeah.
You have it right. You have it right there.
Yeah, exactly.
So
go ahead, Mario.
What we like from your tool is that we know our technology is flexible, and the tool allows us to provide the accurate messaging of what the tool can do, and the illustration of the energy flow, the system behavior, and that is important to understand, that we're dealing not only with a simple converter, but with a very smart converter that can do many things. So that's what we like from your tool, is that in a couple of minutes we can illustrate what we're talking about.
Yeah, exactly. And I kind of went through this a little bit quickly, but the way you can find your product is you can kind of click on it and effectively link it. But when you do that, and I'll show it in a second, but there's also an AI tool attached to it that you can kind of just interrogate, I guess, your product a little bit to help you design these products. So, for example, like from my experience, when you design systems, typically you have to figure out, well, is the overcurrent protection, provided with the units, or is it external? Oftentimes I see bill of materials that are created and they omit what we call the balance of systems. And so with the help of the AI tool, you can ask it your own question, but you can also interrogate it in the design tool and ask it, well, is an external overcome protection required to try and get you effectively to the answer much quicker. And the AI tool will return, at least for your stability series. On the AC side, we need to add a 50 amp 3-phase 3-wire AC breaker. And on a DC side, we need a 1000-volt DC rated 100 amp fuse. And it also provides the references on where this information came from. And in this example, it came from your application guides. And I gotta say, one of the, your particular product, one of the other additional value adds that CE+T provides is really good application guides. And that's very key to be able to take a really flexible converter like yours and get it up and running in the field very, very quickly. So we can interrogate the AI tool to try and help you with some of the knowledge gaps, for example. And with the design tool, you can quickly represent if we need to like add a breaker, for example, or not.
Yeah.
But Mario, talk to me a little bit about the talk to me a little bit about the EV charging integration. How can we add EV chargers?
Yeah, what you have there is a EV charger connected to your DC bus, which is what we see today on the extra fast charging, and we can see an increase in demand from our customers for these type of applications. You also have the other option of having the EV charging on the AC, fed by the AC panel, which is most commonly what we see on CNI type of installation. So basically, it's just a standard EV AC fed, AC coupled EV charger. So in both cases, this is something that the converter can handle. But in both cases, we have to realize that you may not have sufficient energy from the service line to support those EV charger, one. Second, you may not have the economics to be at full power all the time. Meaning that you need something in between your EV chargers and the grid to either shave the peak consumption or provide power augmentation. So, you have a 200 amp, 480 volt service line may not be able to, provide a 1 megawatt of power for your EV charger. So what you're showing you there is what the EV charger does to your grid. So if you would be measuring the kilowatt from the grid and you wouldn't have any buffer in between, that's what you would see. All those purple there are peak demands. And in certain states, you'll have penalties because of these peaks. And in certain areas, you won't be even able to meet to have enough energy to provide to that peak demand. So what we're saying is, as a microgrid, the stability, what it can do in this particular example is to peak shave the demand of your EV chargers, allowing the green line to be seen by your server, which is a smoother consumption, a smoother consumption behavior from your EV charging. So you're adding less stress on the grid. You will be providing a better reliability for your system, and also there's a lot of economics related to shaving that peak there. And then keep in mind that peak there is energy that is now coming from your battery or your solar panel or even your diesel generator, right? So that's how peak shaving works basically.
Yeah,
So that
so
example number one, yeah.
Yeah, so really the economics pay off that you can take like locally generated solar, store it in your battery, and be able to discharge it during the peak times. And that's it's really where you kind of flatten this curve and avoid these peaks, and that helps the utility.
Correct.
And when I look at this design that's out here. And by the way, like, in this particular design, we exceeded 3 ports here. And I just mentioned you could use solar. The Stability series is flexible enough where you can still add a solar.
Correct.
If you exceeded 3 ports, for example, you're using the AC port and using the battery port, and you still want to add support loads and solar, it's flexible enough where you can add solar to a DC bus. Here I would say, yes, you have an MPPT port, but here you really have to set this entire scenario up where your port is bidirectional, but it supports loads and power modes. So typically what we recommend if you do decide to go with this configuration is add a DC-DC converter in between.
Correct.
That handles the MPPT optimization.
Yeah, because on that DC panel, like we said, it's a DC bus, right? This is not a place where you would add directly an MPPT. So what comes out of your solar panel would be variable voltages that you need to convert into a stable voltage that could be compatible with your DC bus. But when you have a configuration like that, you always have to consider the situation where your battery is full, and then you have to also consider that there is no demand, no load. So where would the energy go, right? So at this point in time, what we also have is a curtailment for the DC to DC converter, or if you have an AC coupled solar inverter, the converter will send a signal to the solar inverter to either stop the production or reduce the production of power, because basically battery is full and there's nowhere to put the energy. So every time you add that, you got to consider that the converter needs to control the output of this.
Yeah, exactly. So you're saying your converter is capable of interacting also.
Yes, that's correct.
The optimizer.
Yeah.
Which is, to your point, it's super key for like a stable system. And I guess for those that are not familiar with curtailing or the terminologies, when we're saying curtailing, we're just kind of throttling back the solar until we need or have a place to put it effectively.
Correct. Correct. If your state of charge is 60%, of course you're not going to go curtailing, right? You have to maximize. You have to maximize your battery state of charge. Most of our customers would go to 80%, and then at 80% they'll reduce the charge rate. But there would be some situation where there's no EV to be charged, or the lighting system has already constant demand. So that's why you need to have that type of control. There's no doubt.
I gotta say, there's something else that I like with the Stability is, let's say we delete this line. Imaginary, it can't technically run in just in DC-DC mode.
Correct.
And if you have a DC fast charger that's DC, and you have a DC battery and DC coupled solar, the Stability is capable of running in off-grid mode effectively, and charge your EV or support your DC loads from battery and solar only. And in today's world, I think that's extremely important because you can deploy systems much faster. So there's a trend out there, with these electrification goals that we have. The electric loads are increasing, but the service from the utility is constant, and the panel sizes are fixed, and so consumers have to make a decision if they should be upgrading the service line, which can take time, or upgrading the electrical panel. But with a converter like the Stabiliti, I delete this line for visual purposes. It can be connected, but you can configure this thing in real time to maximize your self-consumption. So minimize power draw and always use as much power locally as possible, which allows you to avoid those expensive service panel upgrades.
Correct. Yeah.
Yeah.
If you go back to your report, I'd like to add another comment here. If you notice your icon for the Stabiliti, you notice a diagonal double lines, right?
Yeah, this one. Yep.
This is a very unique feature. And actually, I would say we're the only one in the market that kept galvanic isolation in their converter. And that's a clear galvanic isolation between the AC and the DC. So what does that do to you in this typical application is that if you have, for example, a ground fault on your solar panel on the DC side, that ground fault will not shut down the EV charging on your AC side. That is such a benefit to our customers today because if you read all the news and the posts on LinkedIn, the range anxiety has now been converted into reliability anxiety. Yeah, I have chargers in my way to work or in my way to my cabin or whatever, but are they going to be functional? And then you look at the failure rates and the root cause of those failures, and it's most of the time it's because you have a leakage to ground. The solar panel needs to be floating, and they're not because whatever reason a squirrel came by, chew on the cable, or something happened. But by having the galvanic isolation, you're isolating these issues to your EV chargers. Now, what's going to happen there is that you'll still have your battery, you'll still have the connection to the AC. It's not going to shut down the entire unit. So it makes it very reliable and very robust. That's what this galvanic isolation does to you. We can discuss about short circuit. We can discuss about safety, but for EV charging, that's a big benefit that adds up to the reliability of the EV charging stations.
Yeah, most definitely. So this air gap, if you will, is extremely important. I think one of the design principles that really need to be taken into account early on is grounding. Very, very important. You can really destabilize your system and make it unsafe. And when you have this air gap or galvanic isolation like the Stabiliti, it really allows you to have a flexible system effectively, that if you have a mismatch in the grounding on AC side to DC, it's still okay to be deployed. But you guys have deployed these galvanic isolations in a unique way. It's not just a big copper coil in a converter. Your converter is fairly compact sized.
Yeah, it's part of our IPs. If you open the box, you'll understand how we do that. We have customers that don't know or didn't understand that we have galvanic isolations, and wood and in what we see on their single line is already a step down transformer on the AC service line, and usually it's a 1-1. And we say, well, why is it there? Well, we just want to have galvanic isolation. And you say, well, you don't need it. It's already embedded into the converter. So that's a great benefit, great cost saving for the customer.
Yeah, it's the way you implemented it. It saves tremendous amount of weight and space too, compared to traditional ways that are implemented. Yep.
Yeah. Now, one other feature that I can see here, imagine that you're in a situation where the grid has been gone forever, and your generator has ran out of gas, and basically your microgrid has the only source available is solar, and obviously the solar would be usually 20%, 30% of what your consumption is. So you're basically limping. You have a limping system because you don't have full power available. So it's very easy to deploy the battery. But then when you restart the whole thing, how does that system behave in Blackstart? The many of our competition would need to have someone going to site and charge the battery. So first of all, you need to bring the battery at a certain voltage with an external charger, with somebody going to site and bringing up the voltage on the DC, and then slowly having the entire system back to life. Okay. Now imagine doing this with thousands of EV charging stations. Imagine that you have, like we have today, climatic changes where you have hurricanes, or you have situation where an entire area has been in outage for several weeks, and when the whole thing comes back, how does it come back? So this system, because of our design as a natural black start, you don't need anyone to go to site. So what this thing is going to do when this thing is, our ecosystem will simply allow the from the PV back into the Stabiliti, still continue to charge the battery. The charging will still go on even if the voltage is below the operating voltage. So at a very, very low voltage, close to 1, 2, 3 volts, we are still going to work. And that's the difference between the C+T converter to another converter, is we're not limited to only 700 volt DC plus and minus 20%. We can go from 0 to 1100 volt DC operation. So this large range of voltage for our DC or DC ports allows us to have a very natural, smooth black starts that allows the converter to work at very low voltage, charge the battery, bring it to a operating level, and have the entire microgrid back to life without the involvement of anybody. So that for us is the definition of black start. No human intervention, natural, restart of the entire ecosystem. That's a big thing about that Stabiliti unit.
Yeah, and that's a huge benefit. And when I started designing systems, it was very shocking for me to find out initially that most battery solar systems still needed the AC grid to come back, restart themselves. Let's say you're in a really bad situation, hurricane, and your batteries are depleted and solar is down, and most systems were not able to restart themselves, black start, from the local on-site renewable solar, whereas this system can do that. And to me, that was always so crazy. Why can you not do that? But black start is also a design philosophy that you have to think about that, consciously when you're designing your product. And that's really another reason I love the Stabiliti series, is it's a design philosophy. And then you carry that philosophy from your converter into the other parts of your system. But it's in today's age, it's extremely important. So to be able to start from local renewable sources of energy instead of waiting for the grid to come back.
Correct. That's
Yeah.
exactly it. Yep, yep, yep. Another great benefit.
And
Yep.
you know, you mentioned that you have a wide input voltage range, you know, of the 100 volts to 1,000 volts.
Actually, you can go 0 volt to 1100 volt DC.
Yeah, yeah. And the power, what's the power level of the stability? I guess let's talk about that a little bit. And at what voltages do you get full power with the unit?
It would be about between 500 to 1100 volt DC.
Yeah, yeah.
So below 500, you would have some derating.
Yeah, still usable.
Yep.
You know, I think it's just a voltage and max current function. You know, we regularly design 350 volt DC systems with this, or 700 volt DC systems, and yeah, to deliver just as well at every voltage level. Yeah.
Correct.
Yeah.
Interesting. So I'm very it's kind of fun to have this discussion and you know, be able to illustrate what we're talking about, because this is becoming some kind of a configurator or a very simple way to describe your scope of work, or you know, prepare your design and get it to permitting. So it's a very fast way to
Yeah, I mean
you know.
the whole idea with this, and you know, the tool is just starting out.
Yeah.
Really, we're focusing on being able to kind of whiteboard at the speed of thought. But you know, by being able to attach real products, we want to make sure you don't just have like this white elephant drawing. So
Yeah.
the configurator tool is continuously evolving, and you know, down the road we'll have things like compatibility checks and be able to size them. But this is a great place to start, and we want to make sure that you know our customers, you know, are able to take their bill of materials away when you design these systems and when you configure them. The other thing that, you know, as designers start using this tool and configuring various microgrids, you know, I've shown the accessibility of the AI tool through the chat function that designers can use to fill in any knowledge gaps that may be out there about how do you implement the system. But there's behind this tool, there's a comprehensive product catalog with a very detailed harmonized data sheet. And you know, manufacturers regularly do release data sheets and samples, but you know, we really focused on making sure that when you do look at the data sheets in the design tool, you have all the relevant information that's needed to be able to implement, for example, your converter in a microgrid. And so you know, a couple of things we talked about that we really, you know, kind of brushed over about how flexible a converter is. But your converter is flexible because of some of the built-in features that it has, that you're able to program it to be either in a voltage mode, a current source mode, or a power source mode, and each port individually can be configured. So between the controllability and the galvanic isolation, you know, it's like having a multi-tool in your pocket. You can really design any power system out there. And you know, one of the works that we're doing with the eMERGE Alliance is we're trying to come up with a standardized way to reference these data sheets, and we call it the interoperability data model. So the work and the groups that we're starting up within the eMERGE Alliance, you know, is really agonizing about, you know, which attributes belong to some of these harmonized data sheets and why, and what value do they add.
Yeah.
So at the end of the day, when you have a data sheet, you should be able to assess if it's for compatibility reasons or whatnot. One example I'll give, Mario, it was without this harmonized data sheet, it was very difficult to even classify what your power conversion system does, or what do we call it, because you have bidirectional ports everywhere. So your system could be a rectifier, it could be a inverter, it can be a converter. So what is it? And typical data sheets out there typically, call these what we now call ports, actually, by their function. So with the eMERGE Alliance, we're trying to level the field so we can easily compare various units with each other. So we can really focus on application deployment. And so we don't call ports by their function, but a rectifier and inverter is a feature of a particular port. So that's some of the work that we do within the eMERGE Alliance. The AI feature is built into the product catalog too, and you can ask it any kind of simple questions to any kind of advanced questions. For example, like explain how to support some unbalanced loads on the AC side. This, I have some experience with personally. Your converter is on the AC side, it's a 3-phase, 3-wire, but it's a delta configuration. So it does not have a neutral. And when you do have to support unbalanced loads, for example, something with a neutral wire, there's still a way to do that, right? Most power systems, EV chargers have a 3-phase, 3-wire delta input, and that's what your converter supports. But how would you support unbalanced loads, like something that requires a neutral, for example, in your system?
You would have to create your neutral, and this would be done with a zigzag transformer. Those are not expensive, and then you would need to use your load to be balanced at the secondary of that transformer.
Yeah.
And then I can see here you have a great description of what a zigzag is. Yeah.
Well, I gotta say, it's not something that's commonly understood what a zigzag transformer is.
Yeah.
But these are some of the things that you can ask the AI, is like, well, help you explain what a zigzag transformer is. And it's used to derive a neutral from a 3-valve delta electrical network. And without digging into it too deep, it it also does it in a way where you don't have a lot of efficiency losses. Now, could you use a delta Y transformer with your converter to support unbalanced loads?
Yeah, sure.
Yeah.
I mean, the Y connection would ensure some kind of a balanced current. The current will be balanced throughout the three phases. So that is possible to do.
So for example, like this transformer could be a delta Y or a zigzag transformer.
Yeah, but remember that it's all about cost, right? I mean, you can go with delta Y, you can go crazy about it, but only a simple zigzag, which are the cheapest form of transformer out there, would do the job, because you already have some kind of I mean, the only thing here is that you need to balance your load, and the zigzag will allow you to do that by you know, taking, I think it's about 1/3 of the current of each phase, and by doing so, you'll be able to you know, balance the phase that are feeding your AC loads. So that is sufficient to do the job, basically. You know, you don't need the big shebang, you know, you know, with all the iron core, and that is some kind of a an overkill for what is required here.
Yeah, and you know, nowadays it's also it's very difficult to source transformers too. So
Correct, exactly.
yeah.
Yeah.
So Mario, I'm gonna shift a little bit to the questions. We have a lot of questions
Okay.
inside, so I'm just gonna kind of read through them and see which ones apply to you, me, or both of us. So one of the questions I see in the chat is, how are the design rules checked? Do the models bring these details from the library? So presently, there isn't an active design rule check yet, but as you've seen, we are setting up the models so we can introduce those design rule checks, and that's why it's important to have these harmonized data sheets, because the design rule checks will take into consideration those data sheets in the library. And when you do end up linking a component from the library here, and by linking, I mean you take the spec sheets effectively here, that brings that model in the back end. And so eventually we'll be able to do design rule checks. There's another question here, Mario, about can the DC output from the PV array be ported with charge control to EV chargers and batteries through the CE+T equipment?
Yeah. Remember that the DC, each one of the DC port can accept an NPPT. So you can have solar panels straight into the DC port. Now, at this point in time, though, you have made a decision that this port would be used for your solar panel, and will be yes, the behavior of that port is MPPT. So the cleaner way to do it, exactly, you need to have the battery on a separate DC port, and there you have the charging algorithm that controls the battery charge. That's how you do it.
Yeah, that's right. Because there's only 3 ports, so with this particular configuration, you couldn't add another DC load, which you put it here. But you can absolutely deploy it with solar, battery, and then configure the port for MPPT.
But keep in mind that we've been talking about a unique configuration with a unique unit. You can add up to 10 to 12 units, and decide which one of these units will have a DC port allocated to PVs, which one of these DC port can be allocated to battery, or which one of the DC port could be allocated to a DC bus with a regulated voltage control. So again, you know, it's very flexible. When you have a group of stability, you can decide what to do with those DC ports, making them source, or making them battery chargers, or making them voltage regulators for a DC bus.
Exactly. Super flexible from that perspective.
Correct.
I'm gonna see if there's a go down the line with the questions. Part load transformer losses under curtailment. Could you shunt access to electrolyzers? I think the attendee wants to know under curtailment
access. I'm not understanding the question. Can you bypass? Can you bypass what exactly? Shunt? You're talking about bypassing something here, bypassing the solar panel, or
Probably, I think, we mentioned that you curtail,
yeah,
and that's considered as a waste, so it could be shunted somewhere else, and
or using the energy somewhere else. Yeah, we
probably
we
when.
we have we have we have customers that are using it in their water heater. Okay, so the water heater is the best load bank you can have. So they're heating up their pool, or they're heating up the water heater for the factory. So yeah, so it's if you want to use, if you don't want to lose any of the solar energy, a resistive load on your DC bus, that would be the cheapest way to go.
Yep, I agree. A question here is, do you see residential DC fast chargers in the future? I guess from your perspective.
Yeah. There is going to be a lot of regulation that needs to be passed before we see that, because we're talking about high voltage DC.
Yeah.
We've done a couple of projects with Duke University, where we had an entire little village at 380 volt DC. We were able to do that because they have their own regulations, and it's in campus and all that. But we've been talking about high voltage DC for several years now, and it's going to happen one day. But it's about regulation, it's about safety, it's about what type of connectors, what kind of terminal blocks. There's a lot of things that needs to change that are pretty basic before we think about fast charger. So, but this is just my opinion, okay?
Yeah.
So
And
that's where we see it.
From my perspective, it's important to also keep in mind that, especially for residential systems, the service to the homes is kind of like fixed, and the panel side fixed. So the only way actually I see the proliferation of fast chargers, which is, let's say, 12 kilowatts to maybe 15, 20, if you need that, is if you move them behind the meter as DC, kind of like we're showing that here. Because otherwise, you're gonna have to go through to make sure that your service is big enough, and if it has to be upgraded, somebody has to pay for it, and you have to upgrade your panels, and it's a lot of cost. Whereas in residential systems, the behavior is very different. At home, you kind of come home and plug in and just top off what you used in a day, and you don't necessarily have to be done in like 10 minutes. So there's a lot of considerations. It's a really loaded question. There's a lot of considerations there.
Correct.
Okay, let's do one more question. If you're proposing a DC alternative to an existing AC approach, can you use this tool to illustrate the operational energy savings between different solutions? Not today, but in a very near future, yes, because we have all the efficiency data of the power conversion systems, and in a very near future we'll be working on efficiency of DC and AC wiring, and being able to size that. So from that you can derive those. Okay, Mario, we're at 2:56. I would like to thank you for this discussion. I'm going to
It was great. Thank you.
definitely thank you. I'm going to switch my screen over quickly for some housekeeping items here. So let me go ahead and make this presentation. So we just went through some of the questions. I would like to remind, all the attendees that we have, and our next microgrid design series is going to be on May 8th and focus on public entertainment facilities. And the Electric Avenue series webinar, which is hosted by Emerge Alliance, is going to be on May 22nd. It's going to focus on the basic of DC fault managed power. The Emerge Alliance is also on the road. So the next place where Emerge Alliance is going to be is at RE Plus Texas, May 14th through 15th, and RE Plus Mid-Atlantic, July 18th through 19th. The biggest RE Plus event is going to be in Anaheim this year on September 9 to 12, where the Emerge Alliance is going to have their live microgrid demonstration at the Grid Edge Theater. To become a Emerge member, you can feel free to scan this QR code. I would highly encourage you to join. One of the biggest tasks that we're trying to undertake under Emerge Alliance is develop these Vanguard standards, but also as these microgrids evolve, developing interoperability standards with the new data models that you've seen at work today. So you can go to the emergealliance.org join, or you can scan the QR code. And at this point, I would like to hand it off to Matt Chafee to close the webinar.
Hey everyone, I wanted to say hi. First of all, thank you, Dusan, Mario. You guys were amazing. Definitely learned a bunch of stuff that I would never have even known. So just drinking through a fire, drinking through a fire hose per se. But if everyone's on, if you wouldn't mind going ahead, taking out your phone, scan our About Decide app, or where it says on the left QR code, it says About Decide. That's going to give you more information about that software you just saw. And then if you want to actually test out the product, go ahead and scan that QR code for Try Decide, because you can have the fun of building your own microgrid today in the matter of, like they said, the matter of thoughts. And overall, if you could give us any feedback as far as how we can continue to improve it, all feedback is necessary, and most definitely grateful for everything. But other than that, I think that's going to be it. If you download the app today and you run into any issues or concerns, like I said, click the feedback. We'll respond within the next 24 hours to get back to you. And, you'll be hearing from me soon enough.
Thank you, Matt. And for those that end up scanning the QR code and entering their emails, we'll be able to share the design that we worked on today. And Mario, I'd just like to say thank you one more time. And
my pleasure, Dusan.
It's always nice talking with you, and especially during design sessions. And to get in touch with C+T, you can scan Mario. You see Mario's contact here and Eric McDonald.
It's great. It's great to have a session where we can join experience with intelligence.
That's right. That's right.
All right. I'll take the experience.
Mario.
I'll be the experience.
Thank you, everyone. And that would wrap up today's webinar session.
Thank you.
Thank you, Mario.
See you soon. Bye-bye.
So, okay.